Hey guys, welcome back to another lesson. This is part 3? Part 3 maybe? Part 2? I can't remember, but we're going to talk about inverse trig ratios today. Just the fundamentals and basics, just how do you find an angle measurement, okay, using trigonometry still, okay? Now, just kind of giving you like a little background here. So we talked about this in the last video, like how 45 degrees was this value. No matter what the ratio was, it always came out to this. We discussed about that with similarity when it came to triangles. Now, today what I'm going to show you is this. What if I want to figure out what the angle is that gives me that ratio? How do I go in reverse? Now, we talked about in the previous lesson that your calculator actually has all of these guys stored into it. Okay, so if I type in, I'll do that right now, sine of 45 degrees, okay, sine of 45 degrees, I get that value, okay? So we talked about how there's a table and how you can look at a table to figure this out, but your calculator has all those values. Now, how do I do the reverse thing, okay? How do I tell the calculator that I have the ratio, but now I want the angle measurement? Okay, how can we do that? Well, it's by inverses. And an easy way to explain this is this. Actually, let's ignore this board for right now. Okay, what's the opposite of addition? Okay, it's going to be subtraction, right? They're opposites of each other. What's the opposite of multiplication? Division. So what's the opposite of a trig ratio? It's this. Okay, so let me just bring it back to this example real quick. If I want to get a by itself, like go back to your normal equation, 2x equals 10. To get x by itself, you did the opposite, right? The opposite of multiplication is division. You divide both sides by 2. X is by itself, and we can see that's equal to 5. Now, over here, same principle. To get a by itself, we do the inverse. So I'm going to take the inverse of sine to both sides. Okay? Now, what is that going to do? This, and the inverse is notated by a -1, just to let you know. This will cancel out with sine here. I'm left with just angle A on that side. On the other side, I have the inverse of sine of this ratio. Now, we already know what this ratio is equal to, right? We already know the angle measurement that goes with it. It's going to be 45 degrees. Now, on your calculator, how do I access this? It's a great question. What you're going to do is you're going to hit the second button that's on here, okay? Then you're going to hit sine. Now, when you do that, you'll see the -1 pop up, okay? That's indicating that, hey, I want to find an angle measurement. Type in the ratio, okay? And there we go. Now, notice it's not exactly 45 because I didn't type in all those lovely decimals, lovely numbers into there, but we get 45 degrees. Okay? So the inverse cancels out this guy. I want you to be careful with something. Okay? This does not mean this. Okay? It's not the same. If you remember back in your algebra career that the inverse looks like a -1 exponent, I mean, it technically is almost, but it doesn't mean you're doing the reciprocal of that value. Okay? This does not work. If you want it to work that way, you have to raise the whole thing to the -1 power for that to actually do its job. Okay, so it's a little side note. I don't want you to get too confused with that. Okay, so just kind of for a future reference in case you do more with trigonometry. Okay, which I hope you do. Trigonometry, there's so much fascinating stuff. I'm only covering bits and pieces of it, but there's a lot more going on behind the scenes that if you're ever curious or ever want to know more, let me know. I'd be glad to teach you on it. Okay, so let me get rid of this. So let's look at this guy right here. I want to figure out the measurement of angle A. Now I'm going to do the same method as before. I'm still going to locate the side lengths and what the relationship is to the angle. Remember, we do have SOHCAHTOA. That can help us figure out what trig ratio we're going to use for this guy. So here we are, angle A. 18 in relationship to A is the opposite side, and then 27 is the hypotenuse. Remember, it's always diagonal from the right angle. O and H is represented by sine. Sine deals with O and H, okay? Sine of A equals the 18 over 27, just like that. I'm not going to cross multiply or anything like that because I'm not finding a side length. I'm finding an angle measurement this time, okay? So to get A by itself, I'm going to take the inverse of both sides. So the inverse cancels sine out here. I just have angle A left. Then over here, I have this inverse of sine of 18 over 27. Now just put this in words. The ratio 18 over 27, I want to figure out what angle is associated with it, okay? So this is where your calculator comes in handy. So you type in second of sine, and then you'll type 18 divided by 27. And when you do that, I'll show you so you guys can see. It would be 41.8 degrees. Angle A, the measurement of angle A is 41.8 degrees for that guy, okay? Pretty incredible stuff. Remember, your calculator has that table, that chart that I was mentioning in the previous lesson. All you're trying to do is figure out what decimal value or what ratio goes with the angle, okay? Now, little disclaimer, do you have to show the cancellation process over here? No, you could jump right to this step. That's perfectly fine, okay? But I just want to let you know what's actually happening here. All right, next example. So I'm looking at angle A again. And I'm going to do the same process. I'm going to locate what the sides are. 6 is my opposite side. 20 is next to angle A. That's my adjacent. What trig ratio deals with O and A? It's going to be tangent, TOA. All right. Tangent of A is going to be 6 over 20. Now, here's another way of writing it. I won't show the cancellation. I'll just go right into this. Right in the inverse. So to figure out the angle measurement, you're going to do the inverse of tangent. So once again, you're going to hit second tangent, type 6 divided by 20. I'll show you right here on the screen. So that's what it's going to look like right there. So it's going to be roughly, what, 16.7 degrees? Just like that. So far, so good? Yeah? All right. Let's do one more example to finalize this concept. Okay? So let's look at this guy. Angle D. Okay? So it's up there. Now notice 3 is the adjacent side, and then 15 is my hypotenuse. What trig ratio deals with those two side lengths? A and H. It's going to be cosine. Cosine deals with A and H. It's so nice to have movable whiteboards. We're going to do cosine of, not angle A, angle D this time. Okay, it's going to be 3 over 15. And I'm just going to go ahead and jump right into the final process. I'll do the inverse of cosine for 3 over 15. Okay, second of cosine, 3 divided by 15. I'll show you what that will look like on the calculator. So it'll be 78.5 degrees. That's my final answer. Your calculator is doing all the heavy lifting in this case. Okay. Could we come up with these answers a little differently? Could we actually figure it out? Yeah. More for a trig course. All right. But for a geometry course, we're just learning some of the basics. Okay. Now, one little note to finalize this guy. Okay. Actually, 2 little notes. Can you give me just a little bit of time? Just a little bit more? Okay. Just please. Good. All right. Let's go back to this guy over here. Okay. When I cancel out, you might be thinking it's a little weird. This is canceling out just the sine, but leaving the angle alone? Like, how's that working? And you could actually type this in your calculator to figure that out, just to see it. Okay? So I'm going to do that right now. Okay. So watch this. So right here, I have the inverse of sine of 45 degrees. See how I get the angle back? Watch this. I'm going to hit enter. And boom. I get the angle back. Okay? See, I told you, they are inverses of each other. You literally are getting rid of that, and all you have left is the angle. First thing I want to talk about. Second thing, okay? You must make sure that your calculator is in degree mode. If it's not, you're going to get an incorrect answer. Now you're probably thinking, wait a minute, we can measure an angle and something else, not degrees? Yeah, we can. All right. What do I mean by that? Well, let me just show you real quick. Okay. If I take my angle, let's say for this guy right here. If I take my angle and I were to just inscribe it in a circle like this, okay? I shouldn't say the word describe, but keep it inside of a circle like this, I should say. All right. Notice that at the circle, this part right here is a radius of that circle, right? What I could do is I can literally take it off and I could try and squeeze in a couple of these guys maybe and see how many radiuses, or radii, for plural, right? How many of those can fit in this space, because that will define the angle for me. Does that make sense? So that's called a radian. Okay, that's what this guy is. All right, a lot of usefulness for it. There's a reason why we do measure things in radians, but like I said, kind of like the outside the scope of geometry a little bit. But if you are interested, I'd be glad to explain it further with you. It's really cool, to be honest. So when you're looking at this, if you see RAD on your calculator, it's measuring in radians, you will not get the same answer, okay? You get something really weird and different. There's a reason for that. So just be cautious. Now, if you're using a graphing calculator, there's an easy way to check that, okay? If you go to mode, right here, and you see right up there, there's degree, there's radian. Make sure degree is selected, okay? If not, you're not going to get the same answers as I'm getting here, and that could be a little bit problematic. If you're using an online graphing calculator, just make sure you select the degree option. It'll be in the options, okay? If you're using a scientific calculator, I believe there's a button on there too that will change it from radian to degree. Sometimes in the screen it will say RAD, that's another way to know, or DEG for degree, all right? But that's pretty much it, my little story there, okay? Just to be very cautious, because as you can see, the calculation part, not difficult. You just have to know two things. One, are you measuring things in degrees? Which we are. And two, make sure you have the right trig ratio for it. Okay? That's it. Thank you. Hope you're doing well, and I will see you in the next lesson video. Take care, guys.